Hello everyone, my name is Parshva Shah and I am a DevOps Engineer at Ashnik. I have total 3 years of experience in cloud and DevOps domain. Now I will try to give you all the real feel about the Docker Enterprise platform by giving you a demo. In today's demo, I will be covering 3 things: showcasing Docker Enterprise platform, sharing the recommended architecture, and deploying an application using CI/CD flow on Docker Enterprise platform. So let's begin. We have Docker Enterprise 3.1 for our environment. There are 3 Linux nodes of RHEL7 being used. One acts as a master node, other acts as a DTR node for storing of Docker images, and lastly a worker node to deploy our application. We have installed Docker Engine version 19.03 on all the 3 machines and UCP version 3.3.1 on the master, which installs and configures Kubernetes orchestration for us. So let me show you the UCP UI through which we can easily manage our platform. On the left hand side you can see various capabilities of the UCP. Over here we can easily select the orchestration between Swarm or Kubernetes. Over here we have selected Kubernetes as a default orchestrator. Apart from that, adding of new nodes is also very easy. Over here we can add additional worker nodes or manager nodes for high availability. The Linux worker node can be selected as a manager or a worker, but the Windows node can only be added as worker nodes. We can also download a client button for various teams to authenticate users accessing through the Docker CLI client, which prevents unauthorized users from making changes in our environment. Managing of users and teams is also very easy using the UCP. Over here we can create user or integrate an existing LDAP server to give control who can see, create or change resources like services, images, networks, volumes, etc. of the UCP of our environment. Apart from that, content trust will allow the UCP to run services that use images signed by the publishers you trust. So over here you can enforce services to use only Docker images signed by the publishers or developers you trust. Access control allows you to give who should access what. Suppose we have 2 teams, namely a developers team or a testing team. So here we can give developers full access and tester a read-only access of the cluster. Apart from that, in Kubernetes we have resources like creation of roles, cluster role. So cluster role contains rules that represent a set of permissions. So over here we can create those permissions. A role binding grants the permission defined in a role to the set of users, or a user or a set of users. So over here you can see you can easily give users what kind of access they can have. So when microservice grows in size and complexity, it becomes harder to understand and manage. So we need a service mesh for discovery, load balancing, failure recovery, observability, monitoring, etc. So UCP comes with by default Istio service mesh. So which has the capabilities which is in the Docker Enterprise platform. So this was a brief introduction about the UCP. So over here you can see the Docker Trusted Registry, which is the enterprise grade image storage solution for Docker images. It comes with a built-in access control which uses the same authentication as of UCP, which allows to authenticated users only to push and pull images from the environment. Apart from that, security scanning feature is also available where it compares each component against the US National Vulnerability Database. Image signing, which is used by the Docker content trust to sign and verify images. So over here you can see we have a demo application repository which stores a Docker image. So over here you can see the report of the vulnerabilities, what are the critical high, medium, low kind of severity levels. You can compare it to the various layers of the Docker image or the components, which is the package or the libraries being used in the Docker image, and the check what type of vulnerabilities are available. Apart from that, you can promote the image to the various environment, to the higher environment, or rescan the image. So this was a brief introduction about Docker Enterprise Platform. Let me share with you the recommended architecture for the production environment. It comes with a minimum of 10 nodes or 40 cores vCPUs. 3 nodes acts as a master, 3 for the private registry DTR, and 4 worker nodes for deploying application workloads. The reason for having 3 master and 3 DTR nodes is for high availability, which follows the raft consensus algorithm to make sure that all the manager nodes that are in charge of managing and scheduling the tasks in the cluster are storing the same consistent state. So one of the trends we are seeing is the adoption of DevOps culture by organizations in their workflow, which helps them to release faster and in an efficient way. So over here, let me show you how and where Docker Enterprise Platform fits into the CI/CD pipeline. So when a developer writes code of an application, they store in a code repository, that's a GitLab for source code and version control. Once the code has been developed, it triggers a Jenkins job, which is for continuous integration whenever new change or a commit has been made in the GitLab. Once the code has been committed, the Maven tool is used to build the archive file for the application code, which is the executable file. Then the Docker Enterprise platform creates the Docker image and pushes into the DTR. Once the image is built and pushed to the DTR, an orchestrator is used to deploy the application. So over here we have Kubernetes for the deployment orchestration. So let me show you an application. So over here I have an greeting app microservice developed in Spring Boot, which takes input as a username and a phone number, and displays a welcome message and the hostname of the container. So over here you can see the username of the user and the hostname of the application deployed. So now let's say the application owner has come up with a new requirement for the application, which is to change the greeting message. So let me show you the GitLab. So over here in the GitLab, we have a Docker file and the create manifest file. So now as the requirement is to change the greeting message, let's change the message. So over here you can see we need to change the message from hi to welcome. So I have committed the change requirement as required. Now the GitLab repository will trigger a Jenkins job. So over you can see a Jenkins job is triggered automatically, which is in the build stage right now, which is creating a new archive file using Maven. some kind of testing using JUnit is done for the application testing. Then it will create a now it is creating a new image. So you can see the image has been created and it is asking for approval. So over here we can see the image contains the vulnerabilities. Like it has 31 critical vulnerabilities, 83 major and 13 minor. So based on this vulnerabilities report, we can have the authority to release the application or not. So over here I am writing a release note updated with new requirements. So in the meantime, I will show you the new Docker image which is published on the DTF. So over here, you can see the new image was being pushed 2 minutes ago, which is the latest image with the requirement specified the application owner, which was to change the greeting message. So over here, you can see now the application has been updated successfully. Now let me So now you can see over here a new image was been deployed with the welcome message with the new host name, which created a new deployment or the containers for our application. So now as we have seen how easy it was to deploy applications using CI/CD flow on the Docker Enterprise platform. So once the applications are deployed, we need to manage and operate also. With Docker Enterprise platform, let me show you how it is done. On the left hand side, you can see we have a Kubernetes tab from where we can see the various resources like namespaces, ingress, services, deployments, pods, etc. of our environment. Let me set the context to the platform tools where our application is deployed. So now you can see over here we have a deployment created of Spring Boot with 3 replicas. So in the replica set you can see the number of replicas indicating how many pods it should maintain. Let me navigate to one of the pods. So over here we have 2 tabs. In the overview tab we can see the configured details about our pod. So and in the metrics tab we can see the CPU utilization, memory and the uptime of the container. We can easily log into the container using the exit. So over here you can see the details about the container. What are the Also we can see the container logs through the UI. So this was in brief how we can manage and operate on Docker Enterprise platform. Hope you all found this demo helpful.